equation that they've given us is in general form, and I'm going to convert it to standard form. That way we can pluck out the things that we know about ellipses when we have them in standard form. And those things are, as a reminder, here are my equation for ellipses from here to here. And these are the equations. Okay, and when I have it in this form, I can pluck out the center of the ellipse. I can pluck out or identify where the foci are, where the vertices are, where the co-vertices are, so on and so forth. So I'm going to use those formulas to help identify our pieces and then graph it. Okay, so first things first, I need to rearrange this general form. So I'm going to put the x pieces, leave a gap strategically. You'll know why in a second. Then the y pieces, and then leave a gap. And I'm going to move that 100 to the other side of the equation, okay? The reason is my very next step is going to be to factor. I'm just going to make a smaller pen mark here. Here, for this one, I'm going to factor out a 4. Here, I'm going to factor out the 9, okay? Make sure I have all the signs right, and I do. Okay, so if I take a 4 out of here, 4, I'll have 4 times the quantity x squared minus 10x. I'm going to leave a gap and close the parentheses. The reason that I'm doing that is because ultimately I want to have x minus something squared. And I'm going to choose a 5, okay? And if you haven't done this before or it's been a while, if you take this middle term, as long as your coefficient is 1 in front of it all, the leading coefficient, if you take the b term, as I'd like to say, or the coefficient of the b term, and you cut it in half, and you put that here, we are completing the square. Now, if I just insert this 5 randomly there, that's equivalent to me having put a plus 25 there. See if that tracks for you. If you multiplied out this x minus 5, you would get a 25 on the back end. We didn't have that in the line above it, so we needed to insert it, okay? All right, let's get back to what we had here. There we go. Now, I'm going to do the same thing with this next piece. I'm going to factor out the 9 because I need this to be a 1y squared. This will be a plus 4y. And then I'm going to leave a gap. And I'm leaving a gap because I ultimately want this to be a y plus 2 squared. Well, if I multiplied that out, that would be the same as me putting a plus 4 there. Now, I have to be careful right now because I have just inserted the 2 red things. I have inserted into an equation items that weren't there before. And remember, the rule in math is if you do it to one side of the equation, you have to do it to the other. So the left side, just by putting the 25 there, this is actually me adding a 100 because of the 4 that's out front. So I need to do it to both sides. Okay, now I'm going to go to that plus 4. Yes, I put a plus 4 here, but really, because there's a 9 out front, that is really me adding a 36 to the equation. So on the other side, I need to add the 36 also. Okay, so what this means is this equation now equals 36. Okay, now I'm going to come back over to the equation of an ellipse. Notice we're getting closer to looking like this. These equations, they have to have an x squared piece, a y squared piece, right? And that has to equal 1. So I'm going to divide everything by 36 so that I can get the right side of the equation to equal a 1. So this will divide by a 36, this will divide by a 36, and obviously that too. Okay, now here's what I have. I have x minus 5 squared over, and when I simplify this, it'll be over a 9. Next piece, I have y plus 2 squared, and when I simplify those, this will be over of 4, and it's equal to 1. There is the equation in standard form. Now that the equation is in standard form, I can pluck out the h and the k for the center. So that will be a 5, -2. Okay. I know that the a for ellipses, a is the largest. Okay. And that means this 9 is a squared. And b, 4 is b squared. So that means b is a 2. Okay. Just to recap, it looks like we have this top one going on, okay? Which means I can start plotting it. My center of this ellipse is 5, -2, so there's the center. Because the a squared piece was under the x squared piece, this ellipse is going to be horizontal. And I go 3 a units out, so 3 units out to get to the vertices. So 1, 2, 3 this way, 1, 2, 3 this way. Okay, there's a vertice, there's a vertice. Okay, B helps us find the co-vertices. So that's the other direction. Co-vertice, co-vertice. Okay, the last piece of information I don't have is the foci, or information for the foci, and that is along the major axes, C units. Now remember, when it comes to ellipses, there is a Pythagorean relationship, but A is the largest. So we would have 9 is equal to 4 plus C squared, which means C will equal the square root of 5. So square root of 5 is about a, 2 point something. So I'm here, going to go to the left and to the right, that amount, and those are the foci points. Okay, I'm going to list them all, but first I'll draw it. This is my vertex. Okay, so I have my center. The vertices are 8, right, so where 8 is, -2, and 2, -2. The co-vertices are 5, 0, and 1, 2, 3, 4, 5, -4. The foci are, now you can start by saying, okay, from this center, right? From this center, the height isn't going to change, but the x value will, right? So I start at an x value of 5, but then I go the left root 5 amount. So there's my x, there's my y, and there's another one. From that 5 for x, I'm going to go to the right root 5 amount. There's my vertices, my co-vertices, and my foci. Right there. All right, I have one more. On ellipses to look at. All right. The statuary hall in the Capitol building of Washington, D.C. is a whispering chamber. Its dimensions are 46 feet wide by 96 feet long, as shown. Okay, basically what this means is if you're the foci points and you whisper, the sound waves reflect off of the walls and reflect and go towards the other focal point. So if you whisper, the idea is the sound waves will travel and land at the other focal point. So you can hear each other whisper. Okay? All right. So what do we need to do with this? What is the standard form of the equation of this ellipse? So here's what I'm going to do. I'm going to put my y-axis right here and my x-axis right here. Okay? So the center is 0, 0, which I like because then I don't have an h to worry about and a k to worry about. Okay, I can see that it's elongated horizontally. So because it's elongated horizontally, A will be the distance from the vertice to the center. Okay, and remember, if they said the entire hall is 96 feet, then half of it, right, will be half of the 96 feet, so 48. So this would be like a negative 48, 0 for a coordinate point, and this would be 48, 0 for a coordinate point. Okay, which means that A, center to vertice, is 48. B is center to covertice. Now, I do know this information, and that is they told us right here that the width of the hall is 46. So we're going to do half of that. So this goes up to 23. This goes down to negative 23. So 23 is our B value. Using that Pythagorean relationship, we can solve, because A is the largest, we can solve for C, okay? We end up with 42.1307, okay? Next, we're going to go to the equation. Because it's horizontal, A squared needs to be here, B squared needs to be here. So this results in an x squared over 48 squared, which is 2304, plus y squared over 529, and this will equal 1, like so. All right, that's it for part A. Let's see what part B says. If two senators standing on the foci of the room can hear each other whisper, how far apart are the senators? Okay. Well, we haven't used the C information at all yet, so I'm kind of glad for this part because we will use our C. C, remember, is center to foci. Center to foci. Well, if that's the case, distance between the foci is 2 of the C values, which would be 84.26. And let's have a label. It is feet. They would be 84.26 feet apart.